intermolecular forces, questions and answers. And these are exam-style questions based on past paper questions I've seen over the years with the answers explained. Which compound forms hydrogen bond when in a liquid state? Take a moment, pause the video if you wish, I'll go to the answer. For hydrogen bonding, we must have hydrogen bonded to either oxygen, nitrogen or fluorine. And we immediately see OH in A, and that is the answer. Looking at the other options, in B, Cl's in group 17, so normally forms one bond. It cannot be bonded to hydrogen, so I don't have a highly electronegative element bonded to hydrogen, and I don't have oxygen, nitrogen or fluorine bonded to hydrogen, so no. C, we do have a polar C double bond O carbonyl group, but no hydrogen bonded to the oxygen. And in D, the nitrogen atom, well, that's oxygen, nitrogen or fluorine. We have nitrogen there, but its 3 bonds are all bonded to CH3 groups. Which pair of compounds is arranged in the correct order? And I see lower boiling point and higher boiling point. Again, pause the video if you wish. I'll take a moment and go on to the answer. First off, looking at the options for A, and I included this one quite deliberately because it comes up so many times. Both molecules have a polar OH group, so I can expect hydrogen bonding. The first option also has a carbonyl group, C double bond O, polar. So I will have dipole-dipole attractive forces as well. They're the wrong way around. HCOOH, methanoic acid as it were, will have the higher boiling point. Of the other options, I'm looking for hydrogen bonding. That would be my quick jump to, and it only happens when we have hydrogen bonded to oxygen, nitrogen or fluorine. Again, that very useful rule. I've got hydrogen bonding in the second option. NH3 ammonia will have the higher boiling point. Answer is D. For the other two, my hydrogen bonding is in the wrong option. It's in H2O. H2O will have a higher boiling point than H2S. B, I don't have hydrogen bonding. Not the strongest intermolecular force present. It will be dipole-dipole. And as we go down group 17, chlorine in period 3, bromine period 4, polarity of bonds would actually decrease. And so dipole-dipole intermolecular forces would decrease in going from HCl to HBr. Two formulae given. Both have the same molecular formula. Two questions. Again, take your time. And for the answers, we might expect them both to have the same boiling point based on their molecular formula. They both have the same molecular mass. Why does ethanol, C2H5OH, have a significantly higher boiling point? Well, the first option, CH3O, CH3, no hydrogen bonding, weakly polar. Ethanol has hydrogen bonding, so is significantly more polar. I will get just permanent dipole-dipole forces in my first option, but the much stronger, and it's important to say, much stronger hydrogen bonding in ethanol. Hydrogen is only directly bonded to oxygen in ethanol, making ethanol have the higher boiling point. What is the nature of the intermolecular forces between molecules of carbon monoxide? For A, there is no hydrogen present, so no, A cannot be. For B, the C double bond O bond is polar, and so we have permanent dipole to permanent dipole forces. And whenever we have permanent dipole to permanent dipole forces, we also have London dispersion forces. Brings us to C. Which molecule is polar? For A, there's no highly electronegative element present. For B, there's no difference in the electronegativity of the chlorine atoms. Comparing the last two, CCl4 is symmetrical, so it cannot be D. Has to be C. CCl bonds will be polar, but dipole moments cancel out in D. Ethane and hydrazine, hydrides of period 2 elements. And 4 short questions. And then explaining why CO is a polar molecule but CO2 is not. For A, the ability of an atom to attract electrons in a covalent bond. For B, the NH bond is the more polar as nitrogen has a higher electronegativity than carbon. Nitrogen further towards the right-hand side of period 2. C, hydrazine has polar bonds and no center of symmetry, but the bonds in ethane are not polar. And D, hydrazine has hydrogen bonding, 1 point. Ethane has London dispersion forces, a second. And for the third, hydrogen bonding is stronger than London dispersion forces, so hydrazine has the higher boiling point. And why CO is polar but CO2 is not? C double bond O bonds are polar due to the higher electronegativity of oxygen, but CO2 has a center of symmetry. There is no net dipole moment, so it's nonpolar. Last, arrange the following molecules in order of increasing boiling point with the lowest boiling point first. First option will have a higher boiling point than the second option, as it has a longer carbon chain, so stronger London dispersion forces. And comparing 2 and 3, both have 5 carbon atoms. 2 will have a higher boiling point than 3, as it is a straight chain, so has stronger London dispersion forces. Answer D. That's it. Hoping you found that useful. If you did, please hit like. Please subscribe to be informed of more content.